All right, so our objective for this lesson is I can solve exponential equations using common bases. Later on in this module, we're going to learn another way to solve exponential equations, but for today, we're going to use that common base as our method. And the essential question, which you're going to be listening for throughout this, is in order to set exponential equations equal to each other, what do they both need? So our topic, solving exponential equation, is going to include 3 guiding questions as I work through these examples. So the first question is, how can I rewrite each equation so that both sides have the same base? And then my second question, if the bases are the same, what equation can I write and solve? And then my final question is, how can I check my answer? So we're going to start out with some very simple equations where the base is already common, and then we're going to move to some more complicated equations. You are going to want to make sure that you're very solid on your exponent rules and on your perfect squares, recognizing numbers that are being raised to the third power, things like that, in order to be successful. So if those are things that you're confused on, I would maybe take a moment and find some information, especially about the exponent rules. All right, so the first question, how can I rewrite each equation so that both sides have the same base? Well, when I look at these two sides of the equation, the base is 2 here and the base is 2 here, so I already have the same base. So then I can move on to the next question. If the bases are the same, what equation can I write and solve? So the cool thing about exponential equations is that when the bases are the same, I no longer need to worry about the bases, and I'm simply solving the equation of what value of x will make those exponents equal to each other. So since they have the same base, then I'm going to say, okay, x plus 1 has to equal 9, since they're both 2 being raised to the certain power. So what value would I have to put in for x in order to make it equal to the other side? Well, that's going to have to be 8. So 2 to the x plus 1 power equals 2 to the 9th means that x has to be 8 in order for those values to be equal. And then my last question is, how can I check my answer? So in this case, I can go back and plug in 8 for that x, and I can say 2 to the 8 plus 1 equals 2 to the 9th, which 2 to the 8 plus 1 is 2 to the 9th, which equals 2 to the 9th, and I know that's going to be true, so I've checked it. All right, so let's look at the example 2. I have 5 to the 4n plus 5 power equals 5 to the n minus 7. So they both have the same base, so I don't need to worry about question 1. So question 2, if the bases are the same, what equation can I write and solve? Go ahead and pause the video and see if you can write the correct equation. So hopefully you got 4n plus 5 equals n minus 7 because they have the same base, and I'm looking for the value of n that will make those exponents the same. So go ahead and pause the video, solve, and check your answer. All right, so hopefully when you solved it, you got n is negative 4, and when you plug that negative 4 back in, you ended up with 5 to the negative 11th is equal to 5 to the negative 11th. All right, so what I'd like you to do is go ahead and pause the video and see if you can work through number 3. It looks a little bit different, but you're going to follow the exact same thing. If the bases are the same, then what equation can I write and solve? Go ahead and pause the video. So the equation that you should have come up with is k plus 2 equals 5k minus 1. Now some of you might be wondering, where did I get that plus k from? So this is where those exponent rules need to be very solid. If you remember from Algebra 1, whenever I'm multiplying the bases, I add the exponents. And remember, we did a lot of work with that in Algebra 1. If you don't remember that, then I would go ahead and start writing down some of those exponent rules. So the first rule that we're talking about here is that when the bases are the same, I add the exponents. So the equation that I end up writing is k plus 2 equals 5k minus 1. So go ahead and pause the video, solve, and check your answer. All right, so when you solved it out, you should have ended up with k equals 1. And when I plug it back in, I have 3 to the first, 3 to the 1 plus 2, so that's 3. So if I have 1 3 here and 3 3s here, I have 4 3s. And that's why I add those exponents. And then 5 times 1 minus 1 would be 3 to the 4th. So my k value checks out. All right, go ahead and pause the video and try number 4. All All right, so hopefully you found that the equation that you can write is negative 4 plus 9 equals v plus 4 plus 2v to the 11, 2v minus 11. So when I solved that out, I ended up with v equals 4. And when I go back and check it, I can see that 10 to the negative 4 times 10 to the 9th is the same as 10 to the 5th. And then 10 to the 4 plus 4 is 8. And 10 to the 2 times 4 minus 11 is going to be negative 3. And so 8 minus 3 is 5. And if you notice, there's a relationship between the numbers that I get here and why I can just set those equations equal to each other and not have to worry about the bases when they're all the same. All right, so what do I do when I see a question like number 5? 6 to the 2x minus 10 equals 36. So the question I'm going to ask myself is, how can I rewrite the equations so that both sides have the same base? So when I look at this, I see that it's the 6 is the base. So when I look at 36, is there any way that I can rewrite 36 so that it has a base of 6? So go ahead and think about that for a second. How could I rewrite 36 so that it has a base of 6? Hopefully you realize that 36 is actually 6 squared. So I can rewrite 36 and not change the value of it by putting it as 6 squared. So now I have a common base, and so what equation can I write and solve? Go ahead and pause the video and finish this problem out. So hopefully you were able to see that x is 6, and when I plug it back in, I can check it. So 2 times 6 is 12, minus 10 is 2, and 6 to the second I know is 36. Fantastic. All right, let's look at number 6. So I see 2 to the p minus 7 equals 8. All right, well, I don't have the same base, so how can I rewrite the equation so that it does have the same base? So when I look at this, I see that the base is 2 here. So chances are I'm trying to make 8 have a base of 2. And remember, we're dealing with powers. So we're not talking about like 2 times 4, but we're looking at what base can be raised to a certain power that will give me 8. So when I think about 2 times 2, so 2 squared is 4. But if I multiply that by another 2, so essentially if I take 2 to the 3rd power, that gives me 8. So I'm going to rewrite this equation as 2 to the p minus 7 equals 2 to the 3rd. So I've changed that base of 8 to 2 to the 3rd. And now I can simply write my exponent equation and solve it. So go ahead and do that now. All right, so hopefully you found that p equals 10. And when I plug it back in for p, I have 10 minus 7, which is 3, and 2 to the 3rd power I know is 8. All right, let's jump down to number 7. So I see that I have a fraction. So I have 7 to the 4x plus 11 equals 1/7. And this is where those exponent rules are going to be really important, because hopefully you remember that when a base goes into the denominator, it's the same as raising it to a negative power. So this is really 1/7 to the 1st power. So it's been raised to the 1st power, but it's been moved to the denominator. It's in the denominator. So what can I do to go to the other side? So if it's in the denominator, move it to the numerator. Or if it's in the numerator, move it to the denominator. That's where my negative exponents come in. So I can actually rewrite this as 7 to the x plus 11 is equal to 7 to the negative 1. So whenever I take that negative exponent, that's going to move it to the other side. So that 7 was in the denominator, and it's being raised to the 1st power, essentially, because there is no exponent on it. So by moving it to the numerator so that it has the same base as this side of the equation, it's to the negative 1 power. So now I have a simple equation to write and solve. Go ahead and finish this problem. All right, so hopefully when you solved it, you got x equals negative 3. And when I go and plug it back in, I'm going to have 7 to the 4 times negative 3, which is negative 12, plus 11 is negative 1. So on the left-hand side, I have 7 to the negative 1st power, which I know is the same as 1/7, because that negative exponent takes it to the other side. All right, go ahead and pause the video, and I'd like you to try number 8 completely by yourself. All right, so for number 8, hopefully you were able to figure out that 32 is the same as 2 to the 5th, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And so once I was able to say that the bases are the same, then I'm able to rewrite my equation as 5 equals 2m minus 9, and then when I solve, I get m equals 7. All right, so 9 and 10 are similar to these problems, but they take it up a little bit more difficult. So let's go ahead and look at example 9. So I have 27 to the 2x plus 6 equals 3 to the 2x. So a big hint right here is this is probably going to be my base is 3. So then I look at 27 and I ask myself, can I make 27 have a base of 3? So I know that 3 to the first power is 3, 3 to the second power is 9, and then 9 times 3 would be 27. So 3 to the third power is going to be 27. So I'm going to rewrite this. And I rewrote the 3 to the third, and then I went ahead and put the 2x plus 6 in parentheses because that's what it was already being raised to, and then I turned it into 3 to the third. So it's really going to be that 2x plus 6 3 times. So now, what equation can I write and solve? Go ahead and pause the video and finish this problem out. Alright, so when I solved it out, I ended up with x equals negative 9 over 2, or you might have said negative 4.5. And I can always go back and check. So I plugged negative 9 halves in where x occurs on both sides. And so 2 times negative 9 halves becomes negative 9, and negative 9 plus 6 is negative 3. And then on this side, I had 2 times negative 9 halves, which is negative 9. So I have 3 to the negative 9th and 27 to the negative 3rd. Well, they're not the same base, so I have to think about 27 is really 3 times. So that negative 3 times 3 gives me that negative 9. You can also check these in the calculator. Alright, so what I'd like you to do is pause the video and try number 10 on your own. Alright, hopefully you were able to find out that y equals 8. If you got that, you can go ahead and skip to the end of the video. If you didn't, then I will explain it right now. So when I look at this, I need a common base, and so I have 4, and I see that 16 could be written as 4 squared. And so the exponent was already y minus 3, so now I'm going to do that twice since I've changed the base from 16 to 4. So now that I have common bases, I simply set those equations equal to each other and I solve. Alright, so for example 11, go ahead and pause the video and try it on your own. Alright, so for example 11, you should have gotten that y equals 2/3. If you got that, you can move on. If you didn't, I'll explain it now. Alright, so hopefully you were able to get that y equals 2/3. If you got that, you can move forward. If you didn't, I'll explain it now. So the first question is, how can I rewrite each equation so that both sides have the same base? Well, 25 is not going to be raised to a power that will eventually get me to 125, so I needed to turn both 25 and 125 into a common base. And so I know that 25 is 5 to the second, and that 125 is 5 to the third. So when I rewrote 125 to the y as 5 to the third, then those became multiplied together, and then 25 became 5 to the second. So once I have the same bases, what equation can I write and solve? I got to write and solve that 3y equals 2. So solving that, I just divide both sides by 3, and I end up with y equals 2/3. Alright, so go ahead and pause the video, and I'd actually like you to try 12, 13, and 14 on your own. Alright, so for number 12, hopefully you were able to get that x equals 2/3 as well. So if you understood that, go ahead and move on to the next one. If not, I'll explain it now. So first of all, I'm asking myself, how can I make them have a common base? So 16 and 8 both can be powers of 2. So 16 can be written as 2 to the 4th, and 8 can be written as 2 to the 3rd. So this is 2 to the 4th, also to the 3x power. So 4 times 3 gives me 12x. And 2 to the 3rd, also to the x plus 2 power. When I distribute that 3, I end up with 3x plus 6. And then solving a basic equation, I end up with 6/9, which reduces to 2/3. For 13, hopefully you were able to get that x equals -1. If you got that, go ahead and move to the next problem. If not, I'll explain it now. So again, 4 and 8. how can I rewrite those equations so that they both have the same base? So 4 is the same as 2 to the power of 2. 8 is 2 to the third. So 2 to the power of 2, and then I also have that 3x in the exponent, so that gives me 6x. And 2 to the third, and then x minus 1. Also, when I distribute that 3, I end up with 3x minus 3. Solving a basic equation, I end up with x equals negative 1. And lastly, for 14, I got x equals negative 2. If you got that, go ahead and move on. If you didn't, I'll explain it now. So 81 and 1/3 are both to the power, they're both powers of 3. So 3 to the 4th is the other way of writing 81. And whenever I see a fraction, I know that I'm going to have that power to a negative because that's what puts it in the denominator, that negative exponent. So 1/3 is the same as 3 to the negative 1 because the 3 is being raised to the first power, and because it's moved to the denominator, that's what makes it negative. So I end up with 3 to the 4th and then 2x plus 5, and then 3 to the negative 1 with that 2x. So when I distribute, I have 8x plus 20 and negative 2x. And so since my constants were already solved on this side, I subtracted 8x. And when I solved it out, I ended up with x equals negative 2. All right, 15 through 18, go ahead and work through. Pause the video. All right, so for number 15, hopefully you were able to get the a equals negative 2. If you got that, you can go ahead and skip on. If you didn't, I'll explain it now. So 8 and 32 have a common base of 2. So 8 is the same as 2 to the third, and 32 is the same as 2 to the fifth. So when I put those together with the exponents that already exist, I end up with 6a minus 3 and 10a plus 5. And then I solve a simple equation that gives me a equals negative 2. For number 16, I got x equals negative 10. Go ahead and move on if you got that. If you didn't, the first thing that I noticed was that 27 and 243, I wasn't really sure about 243, but I knew 27 was a base of 3 to the third. So I went ahead and saw what I could get to, if I could get to 243 by multiplying that by 3 every time. And I realized that multiplying 3 times itself 5 times gives me 243. So that puts me with an equation of 6x and 5x minus 10, and then when I solve it, I end up with x equals negative 10. All right, for number 17, I got x equals 1/2. If you got that, go ahead and move on. If you didn't, I saw that there were already a base of 4 and 4, and so I looked at 62 because I know 4 could be broken down to a power of 2, a base of 2, but I needed to see if 64 could have a base of 4, and it would save me a step. So 4 to the third is in fact 64. So I was able to say 4 to the third is 4 to the first, because if there is no exponent, it's just an understood 1, and 4 to the 4x. And I know that when I'm multiplying the bases, I add the exponent, so I was able to set up the equation 3 equals 1 plus 4x, and when I solved it, I got x equals 1/2. And number 18, I had x equals negative 3/2. If you got that, go ahead and move on. If you didn't, I noticed that the bases were 9, 9, and then I had a fraction. So I know I was going to have a negative exponent. So I can rewrite 81 as 9 to the second, but because it's in the denominator, it needs to be 9 to the negative second. So my bases are all 9, so I can write that 2x plus 4 plus 2x, because when I'm multiplying the bases, I add the exponents, equals negative 2, and then I solve my simple equation, and I get negative 6 over 4, which reduces to negative 3/2. All right, our final two equations, go ahead and pause the video and solve these out. If you understand these, then you are getting the solving exponents using common bases objective. All right, number 19, hopefully you were able to get the x equals 6. If you got that, go ahead and check number 20. If you didn't, I'll explain it now. So first of all, I saw that I had 1/7, 49, and 7. So obviously 7 is going to be my base. So this one is fine. Nothing needs to be done to it.
49 is the same as 7 to the second, and then 1/7 is 7 to the first, but in the denominator, so that becomes 7 to the negative 1. So now that I have that common base, I'm able to just write the equation. So negative 1, 2x minus 10, and then x minus 9, and because these bases are being multiplied, I just add the exponents. So I have a simple equation where I combine my like terms, and then solve, and I get x equals 6. And my final problem, number 20, I see that I have bases of 4, 1/16, and 4. So 4 is going to be my base. 16 is 4 to the second, but since it's in that denominator, it needs to be 4 to the negative second. So I have 4, this 4 and this 4, nothing changed about them because I'm using those bases that they were given in. I'm just rewriting as 1/16 as 4 to the negative 2. So now that I have a common base, I can simply rewrite my equation using those exponents. So because 4 and 4, the bases are being multiplied, I can just add the exponents. So 2x and then plus a negative 2 is the same as just minus 2. So I just brought that down, 6x plus 18, simple equation to solve, and I get x equals negative 5.
All right, the final thing I want you to do is in your notes, I would like you to write down what are 3 common mistakes you think students make, what your summary of this topic is so far. So what are the important things that you need to remember? What are your steps? What is that summary so far? And we will fine tune that tomorrow in class. And then just on a scale of 1 to 3 or 0 to 3, what's your comfort level right now?
All right, so as we wrap this lesson up, what are 3 common mistakes you think students tend to make? What is your summary of this topic? So if I was to say, what was this video about? How would you summarize it? And then what is your comfort level of this topic so far? Make sure in your notes you're writing anything you need to remember, any tips, tricks, whatever, so that when you go to study for your TN Ready exam, and it's been a few weeks since we've done this, it'll be a quick reminder.